Hello! In this guide you'll learn how to build your first Azure Kubernetes cluster with Azure Kubernetes Service. In this video we'll be covering the following 4 steps: creating an Azure container registry, deploying an AKS cluster, running your Dockerized application on this cluster, and we'll go a little bit over a bit of scaling with the AKS service. But first we'll discuss shortly how Kubernetes works. And if you want more information on any of the covered subjects in this video, please read our companion guide on medium.com. Link is in the description. This guide will also go over 2 extra steps, which is a preparatory step of making a test application containerized and a bit of monitoring on the AKS cluster. Well then, let's dive a little bit deeper in Kubernetes. Kubernetes is an orchestration tool which allows for the control and governance of containers. Containers are a virtual machine technology or virtualization technology which run on what Kubernetes calls a node. This node can be either a physical or a virtual machine. However, different containers on these nodes do not share resources. They're all isolated in their own pod. These resources in this pod can be shared. However, this is a different structure than we're going to cover today, which is a single pod in a single container and no other more complicated items. This is the most common and the simplest type of the structures. And to enable all of this, we'll need a container runtime. This container runtime is your tooling, your framework of which containers are set up and are allowed to run. Most commonly used of this is Docker. However, Docker is not the only contender in this. You can also use CRIO, containers, LDX, or any other containerization technology of your choice. The control pane, which is your governance part of Kubernetes, makes decisions about the nodes, like scheduling, dropping existing, deploying new nodes or containers. And all of these in the same control pane or control cluster is your Kubernetes cluster. You can control this cluster via a command line tool called kubectl, kubectl, or as I like to call it, kubectl. In summary, containers are virtualized machines that run on a node. And on this node, they run inside pods, which are shared storage and network resources. And all of these nodes can together form the cluster. Now, before we get into the actual meat of the video and the hands-on part, we'll need a couple of things to be taken care of. First of all, you'll need an Azure account. We advise you, if you're new to this technology or Azure in total, you can use the trial account with 170 euros of credit for a month. This is more than enough to follow this tutorial and get hands-on the nitty-bitty and gritty stuff of Azure and AKS. In any way, shape, or form, you'll need Docker installed locally. For Windows, this is Docker Desktop. For Linux, Mac, and other Unix operating systems, this can be easily installed following the package manager of your choice. Next to this, you'll also need the Azure CLI. Microsoft itself have given excellent examples of how to install this. And after you've installed the Azure CLI, you'll need to install the AKS connection parts of kubelogon and kubectl. This can be done with the command of az space AKS space install-CLI. Follow the steps given by that command and you'll be able to follow this guide to the letter. With the introduction and explanation out of the way, it's time for the hands-on part of this video. As with all services, items, or other things within Azure, we'll first need to create a resource group. This can fairly easily be done by typing in the following command, az for Azure group create We need a name. We'll just call it the PyCalc resource group, and a location. For us making this video, it's West Europe. However, all the applicable variables for location can be found with Azure account list locations. And this, as you'll see, will list out an entirety of a JSON output. So we're just going to output it to the table. And it's much more readable this way. As you can see, there's a heap of locations to be chosen from. Now that we have our resource group and the location connected to it, we can start creating the items necessary for a Kubernetes cluster. One of which is the Azure Container Registry, which is basically Docker Hub, if you're familiar with it. However, it's a private instance for your Azure cloud services. This can easily be created with Azure create. We need to link it to a recently created resource group. We need to give it a name. Azure PyCalc. And a SKU. The SKU basically determines how much storage is available for our container registry. As you can see, it took a little bit of time to create. However, as we can see in our portal overview here, it has been created. And with that, we can push images towards it. And to do that, we need to log into this container registry. We can do that with ACR login and the name of the registry. As you can see, the login has succeeded. And for the next part, we will need to check our output. And right here, we see the login server. This is what we'll need to, in order to push our image that we've either just created with the tutorial on hand, or that we've pulled from the Docker Hub. And to do this, we'll first need to tag it. So with Docker tag, and then our image to the login server, and don't forget to tag it. It's quite easier to find it afterwards. Right. And as you can see with Docker images, both images are here. Both carry the same image ID. As you can see, it now has a different repository and different tag. And with a simple push, Docker push, then with the name and the tag, you can start seeing it push towards our online ACR. This will take a little bit of time as most images are more than a couple hundred MBs, so we'll return after it's done. Alright, the image has finished pushing towards our new container registry. We can check if it succeeded by entering the following command, which is ACR repository list, the name of the registry, and to make it a little bit easier, we'll output it to a table. As we can see, the image is right there on the repository, as right here shown in the overview. There's now a little bit of used storage to state that there indeed is an image right there. With the preparation out of the way, we can now start actually creating this cluster. So to start creating this cluster, we first, of course, column Azure, AZ, and then AKS for Azure Kubernetes cluster. And of course, we need to create a cluster, so we type in create. Now this takes a little bit more attributes than earlier, so we'll go by them one by one. Of course, we'll first need to link it to a resource group. In our case, it's PyCalc RG. We need to give it a name. So that is Kubernetes cluster, Azure Kubernetes cluster. We need to give it a node count. Now there's a little bit to be told here, as the node count for trial versions can only reach a maximum of 2, which is more than enough for what we're using. However, if you want to scale your items or your applications larger than just 2 nodes, so 2 virtual machines, you'll need to get some credit onto your Azure account so that you don't necessarily use the trial version anymore. Of course, we need to communicate with this, so we need to generate an SSH key. We need to attach our container registry. And we need to specify a location. This generation can take quite a bit of time to finish, so we'll continue after it has finished. And we're back with a fully generated Kubernetes cluster. Now we can check with all resources that the entirety of all necessary parts has been created, as well as our Kubernetes service right here. Alright. Now that the cluster is created, we'll need to be able to communicate with it. So as we can see in our list, everything is created properly. But to get the necessary keys or identification, we need to get the credentials from that service. So with the following command of AZ, AKS gets credentials with the resource group and the name of the cluster, we can get the necessary items needed. So as you can see, it merged the necessary configuration within the kube configuration, and to check if everything went correct, we do kubectl, kubecontrol, get nodes. And we have 2 beautiful nodes set up and ready to run for our application. So that is it. We have set up our Kubernetes cluster. However, a bare Kubernetes cluster doesn't really work for us. So we'll demonstrate how to apply a simple application to it. Now, with our written tutorial, you'll see that there is a configuration delivered, of which you will need to change a couple of things in order to make it work. The only thing you need to change to make it work is this line right here, as this is the direct link towards your Azure Container Registry where the image is located. Once you have the configuration changed, with kubecontrol, apply, and then the location of the file, or delivering the file, we can see that the entirety of the service, the deployment, and it has been configured and created. Now we can check this by getting kubectl, kubecontrol, get service. As you can see, we have a beautiful service right here that has been awake for 15 seconds, has an external IP address as has been given to us by Azure, and we can use this IP address to check if our service is online. Now this will take a little bit of time to spool up. And there we go, there is our application. And to check if it's actually fully functioning, we'll state that the number of decimals required should be 1000. And there we go, it generated 1000 numbers of pi. And with a fully functioning Kubernetes run containerized Docker application. Now it's a single application with a single pod and a single container, nice to have, but it is easily overrun. To amend this, we can scale our application within To amend this, we can scale our application within Kubernetes itself. Now we can check that we indeed have a pod here running. And we can scale the amount of pods with a simple command. Kubectl, kubectl, scale, replicas. Replicas is the number of pods you want to be generated. And let's say we just want to generate an extra one. That's where you start the deploy of the There we go. The application of PyCalc, which we've created with the service earlier, has now been scaled. Now we can check this, and as we can see, indeed an extra container is already generating and already spooling up. This is a manual way to scale our pods accordingly. Now, if you think there are too many pods or one of the pods is misbehaving, you can simply delete a pod with kubectl, delete pod, and then the pod name. However, keep in mind that you just have scaled the service to create 2 pods at all time. So after you've deleted it, it will spool up a new pod to replace the one you've just deleted. To scale back the service, you can just reuse the scale commands from earlier and lower the amount of replicas. And if we do kubectl get pods, we can see that our second pod is now terminating, so it will be removed from the system. Manual scaling our Kubernetes application is nice and all, but however, to make it easier, we can also do this automatically. But to be able to do this automatically, our Kubernetes service needs to be of a certain version. And there are 2 ways to check this. One of the ways is the command shown on the CLI. Another way is by just going to the overview, and right here it states that our cluster is Kubernetes version 1.17. Well, that is higher than required. So let's set up an automatic scaler. To do this, we'll first need to execute a command that will enable the automatic scaling of the pods. And that is the following. Now to do this, let's first apply a configuration to our Kubernetes cluster. And with kubectl apply, and then I link to an existing configuration. With the following command, kubectl apply, as you can see here, I'm linking to an existing configuration. We can now see that our automatic deployment, our metric server and everything is automatically being created, configured in order to apply this automatic scaling. Now, to actually execute and activate this automatic scaling, we need to do the following. Kubectl autoscale deployment of PyCalc. And let's say that the trigger is CPU % of 50. And let's say that the minimum amount of pods is 1 and our maximum amount of pods is 2. Now a horizontal autoscaler has been generated right now. To continue exploiting this, we need to apply yet another configuration. the scaler has been applied, and with kubectl we can see that both the deployment and the horizontal parallel scaler are both running and active right now. Now, last point of scaling can be with the nodes within your Kubernetes cluster. However, as I explained before, the trial version for Azure with the €170 of credit does not allow more than 2 nodes per cluster. However, I can still show you how the scaling of a node within a cluster can be done. This is not within Kubernetes itself, this is within Azure. So with AZ, Azure Kubernetes Service, AZ AKS, scale, and then the resource group, the name of the cluster, and then the node count. If we enter this command, it will show an error for the trial version. This basically states that we've reached the quota limit for the service. However, if you're working on a credit base, this will just run for you just fine. Alright, and with this video we've shown you how to relatively easily create the necessary items for your Kubernetes cluster, which is a registry, a resource group. We've shown you how to deploy an actual cluster and apply a configuration and an application towards it. I hope you've learned something from this video, and we wish you a very nice day ahead, and let's get tinkering with Kubernetes, shall we?